Today's progress is going to be a huge milestone for my CNC lathe build. If you are ready for a lot of action, keep watching. In the past videos I assembled the X-axis and prepared the backplate for the spindle chuck. It's about the time to make the X-axis perpendicular to the Z-axis. Both the ball screw and the cards are working smooth. Now the angle between X and Z. The space between the edges of the plate and rail sidewalls is, let's say, constant. I bolted down a cold rolled flat bar as a reference surface for the measurements. I'm going to use a precision square, according to the DIN 875/2. I'm going to adjust the wiggle now. "20 micron tape doesn't fit. Seems good." Nothing fancy was made here actually. Triple checked for the perpendicularity. Some little adjustments were made and I'm happy with the result. After adding shims during the guide's installation, I ran into a little issue. The ball screw didn't race together with them. I checked with the thin shims the difference and had to prepare some slices before installing the top plate. Speaking of the top plate, let's head on to the mill. But before that, let's take a look of what we are going to make now. I designed this part earlier in the ZW3D. It's the base of the ATC turret and keeps the card and nut constrained. 3D CAD software is a bit superior to traditional drawing on the paper. You can have a look at the 3D part you are describing with your pencil before even making it. It's a really simple part between all of the other ones. A drawing should help a bit with all the work on the mill. I decided to make 3 independent drawings to make sure everything will be clearly visible. The drawings will be divided by the features on it. The stock plate is tightened down to the table. The machinist took a look at what is happening and we are ready to go. Milling's done, let's switch to the drilling bits. Sadly, the work area of my machine is too small to do all the work from one stock setup. I moved the plate in the x-axis a bit, checked the parallelism and tightened it back down to the table. And we can push the work forward. I'll be repeating this process until all the holes are made. Mill work is done. Some of those holes will be enlarged on the drill press. When the work area on my mill is not sufficient, the drill press is more efficient. This is a reamer. It will be responsible for making a hole precise enough to handle a locating pin. The fit seems to be a little too loose. Next time I'll be using the reamer on my mill or use it with my taping handle. Pins should do the job anyway. But there were still some features to do. Let's not waste time. The drilling started to feel wonky, and I know why. My grandfather is the best, but there's nothing my best friend can't handle. The plate goes on the cards and the nut surface. And now things are going to get exciting. In order to put the spindle chuck on the backplate I made last time, I've got to face the plate, using the X and Z axis of my machine, ensuring everything is perfectly perpendicular where it has to be perpendicular. But first of all, the cutter has to be mounted somehow to the machine. I'm going to make an ATC turret for that, but come on, we can't wait that long. Getting back to the mill, I will force it to help me with the provisional cutter holder. The drawing I didn't make states to blunt the sharp edges. Now some mounting holes will be needed to put my joining vision to reality. It seems the bolts fit where they belong. That's promising. Alright, let's use some magic to do some stupid things. Please don't laugh too much, this is really an one-time use setup. This tool post is a bit wonky, but I hope it will work for facing the backplate. That's all I require it to do. I even don't expect any good surface finish with it. It will probably deflect as hell. I spent some time and prepared the PC and all the necessary wirings just to fire up the X-axis, the Z-axis, all together with the spindle. The X and Z axis seem to work. Details can be found in my past videos. Yeah! And even the spindle servo has come to life. Let's the fun begin. The runout is quite huge. I'll start off by removing the runout material. I'm taking shallow, slow passes. That one-time use tool post has no rigidity at all. There is visible chatter, but I expected that. Now this. Maybe it's not beautiful, but was made with love. Now the front face. getting somewhere close, I guess. At this point, I thought to shift to a cutter with a sharper edge, just to try if there's any difference. Let's put on this bad boy. I've got it from CNC, link in the description. I think I would call it a nice fit. But what's the runout though? I was not talking about servo runout. That was caused by not tuning the servo regulator before the work. Gotta tune up that servo before working with it. That can be dangerous. I mean, really dangerous. Well, not great, not terrible. I'd call it not a bad sign. The Spindle already survived probably some battles during its life. Also, the fact I'm measuring the outside diameter of the chuck is something worth mentioning. Honestly, I would not be myself if I didn't try that out after all the pain I went through today. This is the moment I was waiting for almost 2 years. I know the machine is not ready yet, but come on, let the little kid in me to have fun with its toy. Keep in mind, these are my first tries. The tool post is not rigid by any means. The feeds and speed have to be adjusted too. That's so sweet. But I discovered the rigidity is much higher when I cut the opposite side. Check this out. I have nothing to add here. I think that when I'll have the real tool post and work a bit on the feeds and speeds, well, I should be happy in my shed with my machine. Whoa, enough. Let's not get too cocky. Today's adventure has come to the end. Nothing bad happened. The cutter holder screw's friction force was lower than the cutting force and the holder moved down. The chuck is on its place. I'm very happy with those trials on that flimsy tool holder and looking forward to put the electronics together. The next steps will be the automatic tool change turret and the pneumatic tailstock. After the first cuts, I can't wait to proceed with all that stuff. It was a pleasure to have you here. If you are curious what's about to happen soon, make sure to subscribe and let me know about your thoughts on this build. Thanks for watching.